Good morning, everyone. We're going to continue our exploration of chapter 19. We're going to do a reaction called the Robinson Annulation. And the Robinson Annulation is a aldol reaction that makes a ring size 6. So we have to figure out which alpha H needs to be removed to make each product. Look at this product. New bonds between 1 and 6. No bonds between 1 and 6 in the reactants. This clearly is one of the alpha H's that needs to go. Look at this product. Where's the new bond here? Let's see. A is bonded to 6. A has no bond to 6. So that's another alpha H that needs to be removed. My apologies, I only gave you one copy of the reactant, so please copy the reactant to do the mechanism with 2 separate outcomes. And we have grabbing H. There's no way to do a combined steps on this one because there's no lone pair on a carbon to start with. I've had students attempt it on tests. They put a lone pair on this carbon and they get a nasty little comment from me saying, octet violation, -1. There can't be a lone pair on that carbon to start with. So don't try to combine this one with the next step. You can't. And we'll go upwards for the first one. Yeah, we got a lot of drawing to do. Sadly, the more organic chemistry you learn, the more drawing you have to do. And okay, what I'm going to do is draw this one like this. Got 1 going to 2. I got the carbonyl here. Anion here, 2. 3 has an isopropyl. Goes to B, which is a carbonyl, goes to A methyl. And 3 also goes to 4, 5, 6. Off of 5 is an ethyl, off of 4 is a propyl. There you go. And as you're settling in, I'll give you the other one here. And this one has A over here. So that's going to be an anion. And it's attached to B, carbonyl. C with an isopropyl, not C3. 3 also has 2 and 1. 2, 1. 3 also has 4, which has propyl. 5 with ethyl, and 6 carbonyl. So there's your 2 results. I hope I got them right. Pretty sure I do. Lone pair has to attack carbonyl, and yes, we can start combining steps finally. We do have to cut our drawings down. I hope you realize it's becoming more and more important. So red first. Yes, the continual blue second, red first scenario. Okay. This is going to hit a carbonyl. Pi breaks becomes sigma, lone pair. Pi breaks becomes lone pair and generates an O-. O-, strong base, grabs H from ethanol. Let's throw some ethanol right here. H-O-E-T. Baby blue. Aldol reaction is over up there. You're going to get something that looks a lot like the thing right below it. Except on carbon 6, there will be an OH. And no double bond between 1 and 6. So I'm just going to copy what I see below. 6 has an OH. I'm copying the molecule underneath. I can go PR, can't I? Yeah. And we're almost finished with that part of the mechanism. You do have to realize this molecule has an extra H in the alpha position. The OET minus you generated just now grabs alpha H number 2. Sigma becomes pi, hydroxide leaves, meow, all that good stuff. And that generates that. Good stuff. Same story on the downside here. Lone pair attacks carbonyl. Pi breaks, whoa. Sadly, some of the stuff on the top of the screen might disappear if I'm not careful. There we go, I think I got it. And then HOET. Where's HOET come from? Well, it's a solvent and it's also what you made in the first step. Baby blue. I'm going to draw what looks like the second product, except on carbon 6 again, there will be an OH. So I'm going to draw it this way, just because it's easier to copy. Got a methyl, got a carbonyl, got an isopropyl, got an acetyl if you're looking for names, propyl, ethyl, hydroxyl, and alpha H number 2. Also, OET minus was just generated. Again, meow. Almost done. Grab H. Sigma becomes pi. Leaving group, not a great one, but good enough when hydroxide or ethoxide are present. And done. Robinson Annulation, as you're copying down, gets its name from the fact that a tree, yes, a tree, gains a ring every year, annually. So the name Robinson Annulation has the ring created annually in its name. It's kind of cool. You know, I'm not big on names, but a name that says something like annulation, I'm cool with that. But just the most important thing to remember is this is an aldol reaction to generate these two products. Aldol ARP, remember ARP from the other day? Aldol reaction product, aldol reaction product. And these are aldol condensation products, ACP. So, not a new reaction. It's a cool reaction. It's how many 6-membered rings are formed in pharmaceutical sciences and in nature. And this is how we do it. And I'll see you on the next video.